Parent functions. What is a parent function? It's a creator of other functions, right? It's the beginning of all the other families of functions. There can be multiple parent functions, though, can't there? There's not just one parent function. There's multiple parent functions, and that's where each of the families of functions come from. Okay? So if we started here, f of x equals x, that's our first parent function. Now, somebody earlier said, that's not really a function because there's no y equals.
F of x is
Oh, wait, there is a y equals? So it's really the same as what? Y equals x? So you guys are remembering, pulling on information that you've learned before, that f of x and y are equivalent for you guys, right? Now, there's some stuff I'm doing in my master's program where they're not, but you don't have to worry about that. When we're doing Algebra 2 stuff, f of x and y are equivalent. This one is telling you right here, you know automatically that whatever comes after the equal sign, it is a function, because this one's written in function notation. Fair enough? Okay, so let's make a table for this function, f of x equals x. When we're talking about parent functions, where do we usually want to start talking about our parent function? When the air comes on, I have a hard time hearing you. I'm sorry. Okay, so we're talking about just x values here, and so yes, we absolutely want to start talking at 0. Is that always true? No, but in general, right? In general. And where do we want that 0 to go on our table? A lot of times we want it in the middle, right? So let's put a 0 right here. If I put a 0 right here, what should go right above it? -1. What should go above that? -2, and so on, right? I'll let you fill that in real fast while I fill it in real fast. So what should go below the 0 then? 1, 2, and so on. I'll let you fill that in. Now let's talk about the y values. Where am I going to get the y values from? Good guess. Where do I get the y values? What does my equation say? If I know the x value, do I know the y value? Why? Because they're equal. Okay? Now, before we go on, I need to talk specifically about the x value. Okay? The variable that we're choosing to represent this is x. It has a specific kind of a name in this particular type of equation. What kind of variable is this? It is the independent variable. That means that the y variable is dependent on what we decide for our x value. Good remembering of the vocabulary. Good job. Okay? So if I know that x is -5, what's y?
-5.
How do I know that again?
Because y equals x.
Oh, because y equals x. So whatever x is, that's also what y is. So if x is -4, y is -4. Do I need to keep asking you, or can you know the pattern already? All right, fill it in then. So what do you think we ought to do next? Graph them? Let's do it. Do you know how to graph points? Do you remember that? Have you slept since then? -5. 1, 2, 3, 4, 5. -5. 1, 2, 3, 4, 5. -4, -4, -3, 3, 2, -2, 1, 0, 0, 1, 2, 2. And stop right here, please, when you get done with this. We need to have a conversation. Are you ready for your conversation? What did I not do that you probably would have done? Connected them, drew a line, right? Why did I not draw a line?
Because there's a line.
Well, because I wanted us to have a conversation, right? Okay? So the conversation that we need to have is, are we allowed to draw a line? When are we allowed to draw a line? Not necessarily. There's one word that I'm looking for, and if you don't mind, I'll help you with it. Is that okay? We have to decide if this graph is continuous or not. I don't want you to get confused about me talking about the word continuous or the word continuing. Do you know the difference in those two? Continuing means it's going to keep going. Keep going, right? That's continuing. I want to know if you think this is continuous. So you really need to know what I mean by continuous, don't you? Continuous means there's no holes, there's no jumps, there's no emptiness anywhere on this line. So how do we figure that out? How do we know if it's continuous or not? Sometimes we can look at a pattern. That's not always true. So let's look where the points are. This point, do you see this point graphed on the line?
No.
Is it really there?
Yes.
Because that would be like what, 1.5? If x is 1.5, is y 1.5? How do you know that? It's what's y equals x. Okay? One of the ways that you can tell if you can connect them or not is if you're given an equation. That's not always the be-all, end-all if there's an equation, but that's a really good start. So do you think this is continuous? Are there any holes or left out parts on this graph? No, so we can connect them. Why should I not connect them like that?
Wait, not like that?
Not like that.
Because it continues?
How do you show that it continues?
You go arrows, right?
Oh, arrows. That would be a good idea. Like that, right? Any questions so far? So now can we talk about the domain and range? Anybody remember what those two words mean?
One is the X and one is the Y.
Correct. Which one's which?
Domain is...
Domain is X.
Range is Y.
Range is Y. I'm just going to put myself little hints right there. Which one of these is my x-axis and which one's my y-axis? So this is x and this is y. Okay. So there's a lot of different ways we can talk about domain. I'm going to try to use several of them as we're talking about them to help you get an idea of how to write down the domain. Okay? We can say to ourselves, what are the x's allowed to be?
All real numbers.
What x's are we allowed to have in this particular problem?
-5.
Another thing that we can think about is, which direction am I talking about when I'm talking about my x values? Which direction is this? Left. And which direction is this? Right. So if I have a graph like this, I can say, how far to the left is my graph going? Now, some people say -5, and some people say -10. But how far is my graph really going? Didn't I just draw this right here? How far to the left does it go? All the way. How far to the right does it go? All the way. How do I write that as far as the domain goes? All real numbers. We can write this. But if you don't know what that means, I need you to write the words all real numbers. This is the symbol that means real numbers. Okay? But I also need you to know how to write domain and range both in another way. Because I don't know which way is going to show up on your SAT and SAT. And remember I told you a second ago, I want you prepared for that. That's the game, right? So we got to do the practice right here. Here's the other way I need you to write it. Negative infinity to positive infinity. Now I'm going to ask you a trick question. Is there such thing as negative infinity? No.
Infinity means
So why did I just write it, right? Infinity means infinity. So why in the world would I just write negative infinity if I just told you there's no such thing as it? What direction am I talking about if I write negative infinity? To the left, right? I mean to the left. So this is really just a notational thing where I'm talking about to the left. It goes all the way to the left and it goes all the way to the right. Are we okay on that? Okay. What about the range? If domain is left to right, what's range? Can I argue with you? Why would I purposely say left to right? Doesn't that really mean negative direction to positive direction? So which way am I talking about when I talk about range? Down to up. Okay? I'm talking about down to up. So how far down do these y values on my graph go? And how far up do they go? So what's my range? All real numbers. The other way to write it? Now, some people have had trouble writing those today, so let me give you 2 hints. You could write 2 circles right next to each other. Or you could turn the paper sideways and write an 8, and then turn it back around. Either way is fine, or you can be a junior and senior in high school and write it this way. Just teasing. Just teasing. Now, in this area down here called special things, a lot of the things we're going to write right here is just the name. There's some other things we're going to write on other graphs, but in this particular one, I would like you to know the name of this parent function. Do you know the name of it? What type of parent function is it? That's exactly right. It's the linear parent function. And watch this magic. When I graph the linear parent function, look what it makes. A line. Now, they don't all work like that. That's just a little magic on linear. Okay? Any questions so far? You good? Let's go to the next one. You know anything about this one? Tell me what you know about it.
Y will be double.
The y is double the x?
Or the x is double the y.
The x is double the y? Tell me why you're using the word double.
Square.
Does double and squared mean the same thing? No, we got to be real careful about that, don't we? Okay. What is this one asking for?
Square.
It's asking for the square. Okay. So whatever value we put in for x, in order to get the y value, we're going to square the x. Right? Tell me that again.
Multiply by itself.
Multiply it by itself. That's really important. Okay. A lot of people forget that that's what squared means. It means multiplying it by itself, and that'll come up here in just a second. Okay. Do you know anything else about this? I know a lot of you guys are really, you want to go right in the same exact order that we did on the last one, but I'm okay jumping out of order a little bit. Do you know the name of this one?
Linear.
Good guess? Okay. Let's talk about that real quick. This is what she's trying really hard to say. Parabola. Okay?
Is that the one?
The parabola is the name of this graph. So this is the name of the shape that it makes when you graph it. It's not the name of the parent function, though.
Doesn't it create like an arch?
That's what a parabola is, yes. The name of this parent function starts with a Q.
Quadratic.
It's quadratic. Okay? All right, now let's go back to the table. Now that we know what it's called, let's go back to the table. It's a parent function, so maybe we might want to start at 0, and maybe we might want to put the 0
In the middle.
in the middle. 0. Can I figure out the square of any number? Is that pretty easy? So we probably want to use the same pattern that we did last time. So does anybody know 0 squared?
0.
Because 0 times 0 is 0, right? Anybody know 1 squared?
1.
Are you sure? Yeah. Okay, so for the record, I'm just telling you up front, it's the very first day, I'm going to question you a lot, even when you're right. Because what I'm saying to you is, are you sure? Why am I saying that to you? I need you to be sure. I can't sit beside you when you're taking the SAT or ACT or Accuplacer or entrance exam or anything like that and say, I can't do that. I need you to be sure so that you're telling yourself, no, I know this is right. I'm good. Okay? So I'm going to argue with you sometimes, even when you're right, just so that you know that you're sure. Fair enough? Okay. So 1 times 1, we decided was 1, right? What's 2 squared? 4. 3 squared? 9. 4 squared? 16. 5 squared? 25. Okay. Negative 1 squared. Wait, what?
Negative times negative is positive.
So negative 1 times negative 1 would be positive 1, right? What about negative 2 squared? Positive 4. Negative 3 squared? Negative 4 squared? Negative 5 squared?
25.
Huh. Wait a second. Will we ever get any y values that are negative using this parent function?
No.
Ever?
Yes.
Think about it.
A negative times positive.
It has to be a number times itself.
No.
Because that's what squaring means, right? That's what we talked about. No, we won't. If we're using this parent function right here, we won't get any y value that's negative, will we? Okay? So let's plot these points. Uh-oh. Is it broken? Did I do it wrong?
No.
Because I went over negative 5 and went to go up 25, and that would put me up here somewhere, right? I don't want to do that. So did I do it wrong? No. What do I do? I just skip that one, right? I graph the ones that I'm able to graph on the graph that I'm given. So where should I start? Negative 3. Negative 3, positive 9. Negative 2, positive 4. Negative 1, 0, 1, 2, and 3. Do I connect it? Are there any values that x is not allowed to equal? So is this function continuous? Yes. I'm also going to tell myself this. Continuous. What about the domain? You already know it. I just asked you the right question. What question did I just ask you? Are there any x's that this is not allowed to equal? No. So what's the domain? All real numbers. Or negative infinity to positive infinity. What about the range?
Will you want us to be writing that on all of them?
Both of them? Yes, until I tell you otherwise. What about the range? All real numbers? I thought that Zach just told me none of these y values are allowed to be negative. Didn't you just tell me that? Because we talked about it. We said if we square anything, it's always going to give us a positive number, right? So my range has to be what? What did you say? All positive numbers? So I can't just put the R and put positive. I can't do that. There has to be another mathematical way to put that. Oh, that's perfect. Y is greater than or equal to what? 0. Why did I put equal to 0? Oh, it can be 0. Okay. So guess what it looks like over here? Where did I start? 0, and how high did I go? So it goes from 0 to infinity. Time for another important conversation. We're going to have about 84,006 important conversations every day. I count them. Not really, I'm just teasing about that. Okay? I've used parentheses on all of these so far, haven't I? Why? What's my other option? A bracket? What does a bracket mean? That means that number is included, right? Is 0 included? So shouldn't I have a bracket here? Why can I not have a bracket here? Do you know where the end of infinity is? Neither do I. Yeah. We have to use a parentheses on our infinities because we don't know where the end is. Okay? Any questions so far? All right, we've already come up with the names. I want you to work on number 3 before you come to class tomorrow, which means most of you will do it at lunch, right? Okay, that's fine. We'll go look at number 4. 3, 4, and 5, whatever we don't get finished with in class today, I want you to have attempted before you come to class tomorrow. Fair enough? 3, 4, and 5. Okay, so look at number 4. What do you know about number 4? Do you know its table? Do you know its graph? Do you know its domain range? Do you know what it's called? Any of it? So guess what this function is called? Square root. I'm going to put something real small in parentheses right underneath this, because sometimes your book will call it that. It'll call it the radical function. And what I need you to know is that this symbol, let me point to it so you can see it. This symbol right here is actually called a radical. We most commonly use it as a square root, and that's why most people call it square root, but the actual symbol is called a radical. Okay? Let's look ahead a little bit at number 5. What do you think that's called? What's that little baby 3 mean? Cubed. So guess what it's called? Cube root. Okay? Alright, so look back at number 4. Let's talk about its table. Where do we normally start with parent functions? 0. Where do we normally want that? In the middle. What's the square root of 0? Oh, 0. Okay. What else do we want in our x column? What do we want here? 1. What's the square root of 1? 1. Okay, good. What do we want here? Oh, see, I would actually not put 2 right there. Do you know why? Because I don't know the square root of 2. What would I choose instead? I would absolutely choose 4. Is it okay for me to jump around like that in a table?
Yes.
Yeah, there's even a song about it. It's like, jump around, jump around. But I don't usually jump around. I did this morning, but that's different. Okay? What's the square root of 4? 2. What do you think I would choose next?
8. No, I'm in 9.
I would actually choose 9. Because I know the square root of 9, right? What is the square root of 9? 3. What would I choose next? 16. And?
4.
25. Because that's 4 and 5. Let's put one more in real quick. What would I put here?
25.
I would put negative 1 in here. Except, what's the square root of negative 1?
1.
You don't know how to do that yet. That's a little bit of foreshadowing, too. You don't know how to do it yet. You will. Okay? Attempt 3, 4, and 5. Fill in what we didn't fill in class. Make a good attempt, and we'll talk about it tomorrow. Okay?